Hello, my name is Henry Nicholes. I am a senior majoring in mechanical engineering and with a minor in Spanish and math. I go to TSU, Tennessee State University, and my project for this summer is the Air Launch Multi-Rotor. Initially, the assignment was dubbed the Air Launch Quad Rotor, and the project involved initially the creation of a quadcopter launched from an aircraft 30 miles out to deploy from a shell and hover over a target for video recording purposes without human control. Some of the problems I ran into were that there wasn't enough time for me to run through all of the possible solutions, picking the best one with the ability to present it within the time frame that I had left. And Dr. Williams noticed this as I began researching the autopilot functions instead of designing from the mechanical requirements. After we had a brief discussion over the issue, we both came out with an agreement of a revised assignment so that I could use my mechanical engineering expertise to its fullest extent. The new project, now revised, involves an air-launched multi-copter design done in SolidWorks with a 3D printout of the prototype, but without the motor, hardware, and propellers. And the requirement is that it needs to be fit into a common launch tube of 42 inches long with a 6-inch diameter. My solution plan was to start with the deployment requirements, which include the impact stresses on the machine, such as first point in time when the machine emerges folded, another point in time when the machine unfolds, and the last time when the machine begins its self-propelled flight. Some of the variables in that include the weather conditions, the motor and propeller size, and the payload weight. Another part of the solution was the flight requirements, which include the battery time, the hover time for the best camera stability, the maneuverability and speed, which are dependent on the variable, once again, of the motors and the propellers, and if time permitted, a bit of theory involving a specified hover height, the performance tested with a few specified variables, and the reflection on potential design hazards that I were to come across in my studies. Some of the methods that I will be using include hand calculations for the static loading of payloads during the flight, use of the SolidWorks finite element analysis tool and stress analysis tools in the design, the use of a parachute to minimize the terminal velocity to something stable around 10 to 20 knots, and to create a 3D model using a printer based on the SolidWorks proven results, which will be a full-scale model prototype. In the future, I plan to use this research towards the development of my senior project, where I would have the time to finalize the design, which include making final motor and propeller choices, the development of an autopilot function, and the hardware setup and final weigh-in for the full testing and correction. These results could also prove useful for the Department of Defense in their unmanned air vehicle usage. Thank you for viewing. My name is Henry Nicholes once again, and my contact information is provided on the slide. Have a nice day.